Okay, here we go. It's been a while since I did a live stream, so I figured I would go ahead and do it again by showing a discussion that I'm having currently about the dilation of time and distance. Okay, so where am I going? Oh, here we go. This one. Okay, so I'm having a discussion with this guy. I guess he's maybe Swedish or something. His name is Bjorn Feuerbacher, something like that. Bjorn Feuerbacher. Okay, so let's look at the entire thing. Starts out pretty rough. I say, I can solve dark matter problems. Scientists have no response for this observation. And I go through with the thing I've explained before. Okay, so he comes with a response and says C is constant. This might be a little bit tedious, but it's pretty interesting the way he approaches it. Speed of light, C isn't constant. That's what I wrote. Scientists have pondered that possibility already decades ago. Did the measurements to test that and found that the idea was wrong. Try again. So he's thinking like I'm talking about a change in the speed of light as far as numerically, I guess. Since the measures of time and distance aren't constant over large distances. Notice I said larger distances. It's very important because locally it's not, there's no change. And what is it? That's supposed to mean your example of 60 kilometers per hour with respect to 60 mile an hour doesn't clear up what you mean here. So he's not understanding what I'm saying. This is what's happening in general relativity. Gravity increases, measure the speed, rate of time over large distances. What less gravity are you talking about? The less gravity outside of the galaxy. And it turns out in most cases the effect is totally negligible. And he's saying try again. So he's already not making too much effort to understand what's going on. It also means the Earth is younger than what they claim. How does that follow? So he's not even following how it means that the Earth is younger. Speed of light. As the speed of imaginary photon increases farther away from the center of the galaxy. So now he's not even understanding the thought experiment. What's that have to do with your thought experiment? Okay, so I guess you gotta spell everything out for him to understand it. This eliminates the need for dark matter because it makes everything move faster with less gravity. It's basically it goes back and forth for a bunch of posts because it's a lot of posts here. It's like 31 posts. So he's going back and forth, back and forth. Same thing. He's Then he says, get an education before you embarrass yourself further publicly. And I'm going to ask him later, why don't you join a live stream? Speaking of publicly, let's join a live stream. I said, this is my second response, right? Or my first response. Now, look at that. Look at that big response. Okay, so my first response is, keeping it short, the speed of light is only constant locally. The amount of gravity is what determines the measures of time and distance, which determine the speed of light. It's not complicated. It's easy to understand, but no, people have a hard time. They have a hard time with it. Already told me. Apparently missed it. Try again. The estimate influence gravity has a passage of time in the universe, hence the speed of light. It turns out in most cases, totally negligible. So he just repeats himself. You, like everyone else, forget about the variation of distance because he mentioned the variation of time. He didn't mention the variation of distance. What variation of distance? What is variation of distance supposed to mean? Now he's acting really dumb. Again, the speed of light is constant locally. The effect of general relativity negligible locally. The same is not true over vast distance. Gravity drops off exponentially the farther away it is from the center of the galaxy. The ground points, so I go into all this. I'm teaching general relativity for free. So, the same is not true over vast distance. Show the math. So he wants me to show the math. And he says gravity drops off exponentially. He says exponentially. Gravity drops off proportional to the inverse square of distance, not exponentially. So he's using the other definition for exponentially, which is right here. There's actually two meanings of exponential. One becoming more and more rapid, or at a greater and greater rate. And then the second definition is the one he's trying to use. It's expressed by mathematical exponent, an exponential curve, which is basically the same thing. Only he's like, making a big deal out of it.
Exponential.
Anyways, what do we got here? Oh, we got Coeur de Lion. Hello. So I'll try to go through this pretty quick so I don't take a whole lot of time here because it's 31 responses. So he's picking a problem with the exponential and saying do the math. Now he's going to go back and forth saying the same thing, even though I'm trying to explain to him what changes the speed of light, that it's the measures of time and distance that change the speed of light. But he keeps going back and forth. It doesn't change that much. It's not going to change that much. So then I finally ask him to join a live stream. So I ask him to join a live stream, and he says, oh, I'm not going to do it unless you tell me what exponential means. And superluminal motion, because talk about superluminal motion. Let me see. I keep telling him do the thought experiment. He says, I did the thought experiment. I simply came to the conclusion that had nothing to do with what's actually seen in outer space. Yeah, right. So he's denying that there's much of a change in the measures of time and distance, okay? Now we're coming here to basically the end part. Let me see. Don't think he responded. No, let me see. Back here, hold on. Just making sure he didn't respond yet, so he didn't respond yet further. So I asked him, would you like to have a live stream discussion about it? And then I go ahead and explain that I never said it's going to be very much locally, just like the Earth is flat locally. But then on a larger scale, the Earth is not flat. So this is what I'm trying to explain to him. So he comes back and says, we can have a live stream discussion as soon as you show that you know what basic terms like exponential, superluminal motion, and rotation curve actually mean. And show that you actually know the relevant equations and can do the calculations. So far, you lack the absolute basics for any meaningful discussion. Discussing dark matter with you is like discussing chicks tactics with someone that doesn't even know how pawns move. Okay. I've been very clear the effects of gravity is negligible locally. Okay, that makes no sense to him. Gravitational time dilation effects can never be seen locally. I guess he doesn't know what gravitational waves are. These can only be seen when you compare two different locations. Well, it's negligible locally. That's still locally. Two different locations on Earth is still locally. That's really so he's not even trying to understand. As you move outside the galaxy, you are covering great distances. It's no longer local. But gravitational time dilation and other similar effects is still negligible over these great distances for at least the third time. Do the math. So I come back and say the math's not corresponding with his observation, with the observation. Yes, the effect is flat locally. Makes no sense to say the effect is flat, yet another scientific term you don't understand. I know what it means by saying the universe is not flat. Well, they want to say it's flat, but it's not flat because that's not what the observations show. Yet, of course, you have black holes. That's not flat. Okay, amount of gravity. The universe never is the same measures of time and distance unless the amount of gravity is the same. That's completely right. Of course, it's right. But for the 10th time, the difference is measured as negligible in most cases. Yes, even over large distances. Okay, do the math. Well, the changes over observations in outer space are moving away from centers of galaxies. This changes our observations of things in outer space moving away from the centers of galaxies. Yes, these changes are observation, but the changes in our observations are caused by this are negligible in most cases, even over large distances. For the fifth time, do the math. This also changes the speed of light, like you had to admit, because you had to admit that it changes. Yes, it changes the speed of light. So he just admitted. After all this, he admits it changes the speed of light. There you go. But the changes in the speed of light are negligible in most cases. Yes, even over large distances. No, they're not negligible. It gets into redshift too. Gravity causes redshift for light leaving the galaxy. Then when it enters a galaxy, it's blue shifted. That's because of gravity. And the bending of light. And so he wants me to do the math, do the math, do the math. Okay, so this is my response. I give him the definition of exponential. You are playing with semantics. There is something wrong with your math because it doesn't correspond with the observation that we see in space. The observations are showing things outside of the galaxy take place faster than inside of the galaxy. You're so confident in your math, why don't you want to do a live stream? Superluminal motion is literally a way to better calibrate the changes of time and distance outside of the galaxy. Things happen much faster than expected because the measures of time and distance are changing the farther away it is from the galaxy. The universe doesn't care how young the Earth actually is. Of course, if you listen to science talks, you know what that means. But anyways, let me see what we got here. We got Coeur de Leon, and that's about it, and nobody else watching. So, anyways, and he hasn't responded yet. He might take some time and respond, but but probably repeating the same thing he already said. He doesn't want to do a live stream. He's so confident in the math Why doesn't he want to do it? If you're so confident in your math, why do you want to do a live stream? Superluminal motion is literally a way to better calibrate the changes of time and distance outside of a galaxy. Things happen much faster than expected because the measures of time and distance are changing the farther away it is from the galaxy. The universe doesn't care how young the Earth actually is. So just notice here that finally got him to admit, yes, it changes the speed of light. Boom. Not too bad. Not too shabby. Not too shabby. So he'll probably think about it, come back and give me another uh, response. That's Bjorn or Bjorn Feuerbacher from Scandinavia somewhere, maybe. So anyway, that's about it. Enough boring content, I guess. But so that's good enough for right now, I think. And everybody take care. And still waiting for somebody to refute what I'm saying. He's saying it's negligible, but not according to our observations. Our observations are showing that it does change the measures of time and distance and does change the speed of light, like he just admitted. So God bless everybody. Take care. See you again soon.